All right, guys, so in this second video, we're going to look at some transformations of parabolas. Now, we've seen a lot of these transformations before in Chapter 2, but we're going to specifically focus on how they apply to quadratics, which are the graphs of parabolas. So horizontal translation, that's a left and right translation. That has to do with h. So that has to do with whatever is kind of on the inside here, x minus h. So you've got one of two things happening. You could be moving either to the left or to the right. So if you have an x minus h, that actually means you're moving h units to the right. If you guys remember from Chapter 2, it's kind of counterintuitive. So if you see that, you are moving h, units. Sorry, said the word move and then wrote it down. H units right. If you see an x plus h, again, remember, kind of counterintuitive, you are moving h units to the left. So let me show you just a quick sketch of what that would look like. So in black, here's the original, just run-of-the-mill parabola here. And then let's say we had an x minus h. That would translate you over here. Okay, so this is if you had an x minus h, and then if you had an x plus h, you would go over here to negative h and start your parabola there. Okay, so this is if you had an x plus h, you would move over to negative h on the x-axis and start the parabola there. All right, a vertical translation is up or down. That's what vertical means. And that has to do with k, and that's that number that's just kind of hanging out on its own on the ends there. So this one does exactly what you think it's going to do. If you have a plus k hanging out on the end of your equation, you're going to go k units up. And then if you have a minus k on the end, you're going to go k units down. So the horizontal kind of does the opposite of what you think it's going to do. This one does exactly what you think it's going to do. So again, let me give you just kind of a quick little sketch. Here's your original parabola. And then if you have a plus k, you can go k units up like this. Or if you have minus k, you would go k units down like that. Okay, so that's a vertical translation. So if you started at the origin, you would be moving right up or down on the y-axis. All right, a reflection has to do with the value a out front. So a reflection has to do with the sign of a. Not a itself, but just whether a is positive or negative. Okay, so if a is positive, your parabola is right side up. And if a is negative, your parabola is flipped upside down. Okay, so again, quick little sketch. This is just a normal parabola like this. In this case, a is positive. That means your graph is right side up. Here's your reflection. If a is some sort of negative number, then your parabola will be flipped upside down. And you actually did that in section 4.1 when we were talking about maxes and mins. All right, and then a dilation is either a stretch or a compression, and that has to do with the value of a. Okay, so like the number of a, not its sign. The sign gives you the reflection, the actual number itself gives you the dilation. So if a is something that's bigger than 1, you are going to have a vertical stretch. And if a is something between 0 and 1, you're going to have a vertical compression. So remember what happens here is your graph gets narrower, and what happens here is your graph gets wider. All right, so one more time. Here's your original parabola in black. If you multiply by some sort of value of a that's bigger than 1, you're going to end up with a narrow parabola like this. So this is some sort of value of a that's bigger than 1. And then if you multiply by a fraction, you're going to have this super wide parabola like this. Okay, so sorry, that says 0 is less than a is less than 1. So some sort of fraction value. All right, so let's look at two quick examples. We're going to first translate them into vertex form and then use all of our context clues to graph them. All right, so this one right here, remember when you're translating into vertex form, you have to factor out whatever number is in front of the x squared. So we're going to start with that. We're going to take a -2, factor it out. So if we divide it out of here, I'm left with an x squared. If I divide it out of here, careful, I'm left with a -2x. And then we're going to leave some space to do the completing the square step. And then remember, you just kind of push your +1 over to the side. Okay, so we do the completing the square step. We start with the -2. Start with the -2, cut it in half, we get -1. And then take -1 and square it, and we get +1. So that's the number that I'm going to add right here. Okay, that's my new number. So I'm adding a +1. But remember, even though this looks like a +1, and obviously it does, it technically is a -2 times 1. Okay, so what I'm going to do is I'm going to balance it out on the other side. So I'm going to subtract a -2 times 1. Okay, so whatever this number is, you always subtract it, and of course that changes to plus a positive. So let's clean this up a little bit, see what we have. So this is -2. To finish off my completing the square step, I'm going to write this as a perfect square trinomial. This is like this. This number right here is always half of this number, and then I have +1 +2, so I'll have a +3 on the end. Okay, so let's make a note of everything that we've got going on in here. Okay, so what this -1 is going to do is this is going to move our graph 1 unit to the right. Okay, so 1 unit to the right. Okay, this +3 is going to move our graph 3 units up. And then this -2 does two things. Remember what the negative does, it flips it upside down. And then it stretches by a factor of 2. Okay, so let's sketch that. Okay, so 1 unit right and 3 units up means our vertex moves right here. Okay, so instead of starting at the origin, we go 1 unit right, 3 units up, and that's our vertex. So just a quick little note, remember when we're in vertex form, the vertex is the opposite of this number, and then this number for y. So now what we do is we know we're going to be flipped upside down. We use this -2 as almost like a slope, because remember with a parabola, you know you're going to need 2 other points in order to get the shape. We know my vertex lies on the axis of symmetry. Okay, so this -2, like I said, you almost use it like a slope. So from this point, I can go down 2 and then over to the right 1, and I can leave another point right there. And because this is an axis of symmetry, I can flip that point over here. All right, so now we just connect the dots. We know that's our highest point because it's the vertex, and that is our parabola. You can see it's a little bit narrower than a parabola would be normally, and the negative has flipped it upside down. Okay, so let's take a look at this one. This one, I don't have an x term, so technically it's actually already in vertex form. And I think we saw one like that in the previous video. So this is technically already in vertex form. So it's like having 2, and then this is just, you know, an x minus 0, technically, squared plus 7. So there's nothing that we need to do to get it into vertex form. It's already there. So this does not move left or right at all. The x value is 0. What this does, it moves it up 7 units. So it's going to start right on the y-axis. And then this 2, it's still right side up. Still right side up because that's positive. What it's going to do is stretch it by a factor of 2. Okay, so let's set that up. So I'm moving up 7 units, so I'm going to leave myself some space to do that. So I'm not moving left or right, I'm just moving 7 units up. 6, 7, so my vertex is right there, which means, remember this is also my axis of symmetry. Okay, so I'm going to use this positive 2. Remember, it's almost like a slope. I can go up 2 units and then over to the right 1 to plot my next point. And then I can use my symmetry to plot another point over here. And that is my equation. So if this were like a fraction, maybe this were like a 1/3 or something like that, I would go up 1 over to the right 3 to plot another point. And then you could see that would make it nice and wide.